Morning to one another. I am Sadish Kumar from ECE department, MAM School of Engineering. Now I am going to explain some important points for VLSI designs, CMOS VLSI design. The outline of VLSI design. The first one is circuit pitfalls, deductive bezels, given circuit and symptom, diagnosis, cause and recommended solution. All these pitfalls have caused failures in real chips, noise budgets, reliability. Bad circuit. The circuit, for example, 2:1 multiplexer. The 2 is the input and 1 is the output. And a symptom, the mux works when selector D is 0 but not 1, or fails at low VDD, or fails in SF corner. Principle and solution. The bad circuit 1, and the circuit 2:1 multiplexer, and symptom mux works when selected D is 0 but not 1, or fails at a low VDD, or fails in SF corner. The principal threshold drop, X never rises above VDD minus VT. VT is raised by the body effect. The threshold drop is most serious as VT becomes a greater function of VDD. The bad circuit 2, for example, the bad circuit 2 is the latch circuit. The symptom load A 0 into Q, set pi is equal to 0, eventually Q spontaneously flips to 1. The principle and solution you are given. The bad circuit 2, the circuit and the symptoms. The principal leakage, X is a dynamic node holding value as charge on the node. Eventually, subthreshold leakage may disturb charge. Solution. The symptom load A 0 into Q, set pi is equal to 0. Eventually, Q spontaneously flips to 1. The circuit and latch, the symptom load A 0 into Q, set pi is equal to 0, eventually Q spontaneously flips into 1. The principal leakage, X is a dynamic node holding value as charge and the node. Eventually subthreshold leakage may disturb charge. Solution, staticize node with feedback or periodically refresh node. Requires fast clock, not practical processes with big leakage. The bad circuit 3, the circuit domino and gate, symptom precharge gate Y is equal to 0, then evaluate, eventually Y spontaneously flips to 1. The circuit domino and gate, the symptom precharge gate Y is equal to 0, then evaluate, eventually Y spontaneously flips to 1. The principal leakage, X is a dynamic node holding value as charge on the node. Eventually subthreshold leakage may disturb charge. Solution. The circuit domino and gate, the symptom precharge gate, then evaluate, eventually Y spontaneously flips to 1. Principal leakage, X is a dynamic node holding value as charge on the node. Eventually subthreshold leakage may disturb charge. Solution keeper. The circuit pseudo NMOS or symptom, when only one input is true, Y is equal to 0, perhaps only happens in SF corner. Principal solution. The circuit pseudo NMOS or symptom, when only one input is true, Y is equal to 0, perhaps only happens in SF corner. The principal ratio failure, NMOS and PMOS fight each other. If the PMOS is too strong, NMOS cannot pull X low enough solution. The circuit pseudo NMOS, or this is the uh, circuit diagram of pseudo NMOS or gate. The symptoms when only one input is true, y is equal to 0, perhaps only happens in SF corner. Principal ratio failure, NMOS and PMOS fight each other. If the PMOS is too strong, NMOS cannot pull X low enough. Solution, check that ratio is satisfied in all corners. The bad circuit and latch. The symptom Q stuck at 1 may only happen for certain latches where input is driven by a small gate located far away. The principal solution. The bad circuit 5. The circuit and latches. The basic building block of latch circuit. The symptom Q stuck at 1 may only happen for certain latches where input is driven by a small gate located far away. The principal ratio failure, again, series resistance of D driver, wire resistance, and gate must be much less than weak feedback inverter. Solutions. The bad circuit 5, the circuit and latch. Symptom Q stuck at 1 may only happen for certain latches where input is driven by a small gate located far away. The principal ratio failure, again, series resistance of D driver, wire resistance and gate must be much less than weak feedback inverter. Solutions, check relative strengths, avoid unbuffered diffusion inputs where driver is unknown. The circuit domino and gate, symptom precharge gate while A is equal to B is equal to 0. So Z is equal to 0, set pi is equal to 1, A rises, Z is observed to sometimes rise. The circuit domino and gate, the symptoms precharge gate while A is equal to B is equal to 0. So Z is equal to 0. Set pi is equal to 1, A rises and Z is observed to sometimes rise. The principles of domino and gate, charge sharing. If X was low, it shares charge with Y. The solutions are given. The circuit domino and gate, the symptoms precharge gate while A is equal to B is equal to 0. So Z is equal to 0. Set pi is equal to 1. A rises. Z is observed to sometimes rise. The principles charge sharing. If X was low, it shares charge with Y. Solution, limit charge sharing. Safe if Cy greater than Cx or precharge node X2. The circuit dynamic gate plus latch. The principles and solution. The symptom precharge and gate while transmission gate latch is aback. Evaluate when latch becomes transparent, X fails. The principal charge sharing. If Y was low, it shares charge with X solution. The circuit dynamic gate plus latch. The symptom precharge gate while transmission gate latch is aback. Evaluate when latch becomes transparent, X falls. The principal charge sharing. If Y was low, it shares charge with X. Solution, buffer dynamic nodes before driving transmission gate. The bad circuit 8. The circuit latch. The principles and the solutions are given. The symptom Q charges while latch is aback, especially if D comes from a far away driver. The bad circuit 8, the circuit latch. The symptom Q changes while latch is aback, especially if D comes from the far away driver. Principal diffusion input noise sensitivity. If D less than Vt, transmission gate turns on most likely because of power supply noise or coupling on D. The solution right may be right or wrong. The bad circuit 8, the circuit latch. The circuit diagrams are given below. The principal diffusion input noise sensitivity. If D less than Vt minus Vt, the transmission gate turns on most likely because of power supply noise or coupling on D. The solution buffer D locally. The symptom Q changes while latch is aback, especially if D comes from a far away driver. The bad circuit 9, the circuit anything, and symptoms some gates are slower than expected and legally principles are written. The bad circuit 9, the circuit anything, symptoms some gates are slower than expected, principal hotspots and power supply noise. The principal hotspots power supply noise are given below. Noise. The sources power supply noise, ground bounds, capacitive coupling, charge sharing, leakage, noise feed through, and consequences increased delay for noise to settle out or incorrect computations. The reliability, there are two different errors are considered. The first one is the hard errors and the second one is the soft errors. It is the basic diagram for reliability. It is the timing diagram. The diagram depending upon time and failure in rate. The three important factors are considered in the reliability. The first one is the infant mortality and useful operating life and wear out. The electromigration. The electron wind gases movement of metal atoms along wires. Electromigration leads to open circuits, more significant unidirectional area depends on density JDC. The exponential dependence on temperature, Black's equation, MTTF proportional e power EA divided by KT divided by JDC whole to the power of n. Typical limits JDC less than 1 minus 2 MA divided by micrometers squared. See videos. The self-heating, the current through wire resistance generates heat. Oxide surroundings wires is the thermal insulator. Heat tends to build up in wires. Hotter wires are more resistive, slower. Self-heating limits AC current densities for reliability. Typical limits JRMS less than 15 milliamps per micrometers square. The hot carriers. Electric field across channel import high energies to some carriers. These hot carriers may be blasted into the gate oxide where they become trapped. Accumulation of charge in oxide causes shift in Vt over time. Eventually, Vt shifts too far for devices to operate correctly. Choose VDD to achieve reasonable product lifetime. Worst problems for inverters and NMOS with slow input rise time and long propagation delay. Positive feedback leading to VDD. Ground short major problem for 1970s CMOS processes before it was well understood. Avoid by minimizing resistance of body to ground per VDD. Use penalty of substrate and well taps. The P substrate and the substrate tap, N well and N well are max, the well tap. The ground VDD, the guard rings, the latch up risk greatest when diffusion to substrate. Diodes would becomes forward biased. The surround sensitive region with a guard ring to collect injected charges. These are the diagrams for N guard ring and P guard ring. It consists of N well and VDD and P plus P substrate. The P plus guard ring, it considered N plus and P substrate and ground. These are the importance in guard rings. It can be used as the produce on the guard rings. The over voltage. The over voltage means the high voltages can damage transistors, and the voltages damage for the following reasons. The first one is the electrostatic discharges. And the electrostatic means the current discharging into the circuits. The oxide arcing and punch through and time dependent dielectric breakdown. It means the TDB. It accumulated wear from tunneling currents. It requires low VDD for thin oxides and salt channels. Use ESD production structures where chip meets real world. It is the summary of the VLSI design. The static CMOS gates are very robust, will settle to correct value if you wait long enough. Other circuits suffer from a variety of pitfalls. The trade-off between performance and resistance and robustness. The very important to check circuits for pitfalls. For large chips, you need an automatic checker. Design rules aren't worth the proper they are printed on unless you back them up with a tool. The soft errors. In 1970s, DRAMs were observed to occasionally flip bits for no apparent reason, ultimately linked to alpha particles and cosmic rays. Collisions with particles create electron hole pairs in substrate. These carriers are collected on dynamic nodes, disturbing the voltage. Minimize soft errors by having plenty of charge on dynamic nodes. Tolerate errors through ECC redundancy.